Good morning, everyone. We are in trouble with the internet connection here at LAKI, but we will record it and it will be on the web at least tonight, the latest tonight. But today we have two places that we are visiting. LAKI is the first place here in the mountains, and we are going to have some information and talk from both Berglind and Jóhannes from Katla Geopark, and then the students are going to take some pictures, and they're going to talk about these pictures, and they are going to tell you what is on the picture, what senses they use to observe and reflect, and what influence it did have on them, and why they choose that subject. And hopefully we will be able to put these pictures from the students on the Instagram account in the project. But we will start with Berglind.
Good morning, everyone. My name is Berglind and I am the Geopark Manager of Katla UNESCO Global Geopark. And we are now located right in the middle, or right by the LAKI crater row, which is one of the most significant places in the history of Iceland. Bakka. Okay. And even on a global scale. This is a volcanic fissure that is about 25 kilometers long and consists of about 130 to 140 craters, known as the LAKI craters. And they were formed in the Skafta fires, which is one of the largest eruptions on Earth since the Ice Age. And the eruption lasted for about 8 months, started in June, almost 240 years ago. It had a huge consequence not only for Iceland, but also on a global scale, quite significantly in the northern hemisphere, for years following the eruption. And during these years, there was a man, Reverend Jón Steingrímsson, who was preaching in the area in the farms below. And he documented a detailed description of the events that happened during the fires. He also became for what is known as the Fire Mass, which tells the story of when the townsfolk, who were terrified of the lava and the eruption, were worshipping in a church here, and he begged God to show them mercy. And that is precisely what happened. The lava flow ceased, and they were spared on the church as well. I have gathered some of his descriptions to give you a feeling of what it must have been like surviving these events and living during these difficult 8 months. But before we start, I want everyone to close their eyes for a few minutes and travel back to 1783. Let's imagine that we're in the area below here in the grasslands. And imagine that it's June and the summer has just started and the newborn lambs are all out and about. And in the area around us, there are flourishing farms, and around each farm there are grasslands with many animals, there's flowers, there's bushlands, there's river streams with clear and crisp water that you can just drink out of. There are horses, sheep, birds, and the men and women are at work, and the children are at play. The sun is shining and the flies are buzzing, and the animals are grazing, and it's very peaceful. There's enough food for everyone living in the area, and the weather is warm, and everyone is looking forward to a great, bright summer, finally, after a typical cold, harsh, and dark Icelandic winter. Now open your eyes. It all started with a series of small earthquakes in 1783. But shortly after breakfast, on June 8th, a black, what looked like a sandy cloud, originating from these mountains here, these craters, started coming closer down to the farms. And the dark cloud spread over the area, and it was so thick that it caused total darkness. Sandy powder fell from the clouds and covered everything like it was black snow, and as one walked through it, a path of footprints could be made into it. And as it started to rain, this black powder turned into a thick liquid, something like black ink covering all the vegetation. And the skies became heavily clouded with steam, and bitter rain fell from it, causing unbearable soreness to the eyes and bare skin, as well as terrible dizziness. As the rain fell, it burned holes in the leaves and left scorch marks on the hides of newly born sheep. The dark cloud kept growing in size and height, and soon could be seen from all over the country. And the sun, it appeared red as a fireball, and the moon as red as blood, and bright red sunrise fell on the earth. Cinder and threads, which Johannes has brought along, similar, is what fell from the sky. And they had a bluish hint, like a blue color. And the rain soon started to have a bluish color as well, and the smell in the air became so strong and bad that people had a very hard time breathing, and some could even barely breathe at all. They described it as a smell of rotten eggs and bitter sea, whatever that smells like. And then soon a wall of fire with flames reaching high into the sky arose through the cloud of smoke. And it is believed today that these were lava fountains, reaching almost 1.5 kilometers into the sky, and the black cloud, an eruption plume filled with ash, almost 15 kilometers into the sky. And the river Skaftá, which is just a little bit to the west of here, some of us crossed it this morning. It's usually quite powerful and difficult to cross, but as these events were occurring, the river almost completely dried up, and lava from the eruption came gushing down the canyon, which used to be much bigger. And it splished and splashed with frightening speed, crashing, roaring, thundering, crumbling, screeching even, like broken glass in some events. And it slowly filled the canyon, and in the end it flowed over the lowlands. And some people have said it seemed like fires were forcing itself out of the ground everywhere, here and there, and the heat was so much and fire simply came from nowhere. And it spread around and diminished many of the farms in the area. And in only a matter of a couple days, maybe 4, the lava had already traveled 30 to 40 kilometers into the lowlands. And there was clouds of hot vapor and fog made visibility very limited. And claps of thunder with flashes of lightning terrified everyone. And the farmers and families who were living in the area had to flee to higher grounds, and many of them tried to evacuate their animals from the lava flows, the boiling waters and fires. But they probably would have been better off just slaughtering them right away, because the animals didn't have much chance of survival. The grasslands, which were green and luscious before, faded into a grey color and died. And everything became covered with ash or sulfur precipitation, like almost frost, and completely ruined all grazing and slowly killed the animals by causing famine, hunger, and illness. And the snouts, nostrils, and feet of the livestock grazing or walking on the grass turned bright yellow and raw. And the flesh and the milk of animals dwindled one after the other. Soon the animals just withered away one by one. And the horses, they lost, for example, all of their flesh. The skin began to rot off along the spines of some of them. And the hair of the tail and the mane rotted off and came off if it was pulled sharply. Hard, swollen lumps appeared on the joints, especially on the fetlocks. Heads became swollen and disfigured. Jaws were so weak that they could hardly bite off or eat grass, and as what little they could chew fell out of their mouths again. The bones shrank and they lost the marrow. And the sheep, they were affected even more wretchedly. There was hardly a part of them free of swellings. Migratory birds that were in the middle of their nesting period fled so quickly that they left behind their recently laid eggs. But they were unedible due to ill odor and sulfurous taste. And as time passed, flocks of birds were found dead or disoriented. The fish died in ponds and streams around, and all the water went tepid and became light blue in color. The rocks and gravel slides turned gray. All the plants burned, withered, and turned gray, one after the other. Iron turned rust red, timber became gray from salty and sulfurous rain. Poison simply kept falling from the sky and turned into a haze that traveled all over the northern hemisphere. These descriptions that Reverend Jón Steingrímsson has documented so carefully are one of our best references to the events of the Skafta fires. And as you have heard, they were nothing short of catastrophic. The eruption resulted in what is known as the haze famine, móðuharðindin, or mist hardships, and caused the worst environmental and socio-economic disaster in Iceland's history. The effects of the eruption reached far, and the sulfuric aerosol cloud produced by LAKI generated a persistent haze or dry fog that hovered over a large part of the northern hemisphere during the summer of 1783. The haze was at its densest all over Europe only a few weeks after the onset of the eruption. But by the beginning of July, it had already spread to Russia, it had spread to Siberia, and it had even spread to China. And at its peak, it covered about a quarter of the Earth's surface. Or all the land north of the 30th degree latitudinal on the globe. And it has even been argued that the French Revolution might have begun due to the eruption in the LAKI, because of the enormous influence the mist had on the climate and farming in Europe. And toxic ash ruined pastures, so livestock got sick with a disease called gattur, which is basically fluoride poisoning. And as a consequence, many of them simply starved. The weather cooled due to the mist, and sea ice reached the coast. And then when winter arrived in 1783 and 84, livestock collapsed from starvation and disease due to the toxic volcanic material. People, as a result, died of hunger. During the hardship, it is believed that 1 in 5 Icelanders, or about 10,000 people, died. And around about 75% of the farm animals also. In the area here below, called Fljótshverfi, Meðaland and Síða, it is believed that about 40% of the population died. At least 20 farms were covered with lava, and another 30 were so damaged that they had to be temporarily abandoned. The huge amount of poisonous gases emitted from this eruption is believed to have stayed aloft in the atmosphere for over a year. And this might explain why the northern hemisphere temperature was a couple degrees below average for 2, 3, maybe 4 years after the eruption. And just to give you a kind of feeling of how much volume erupted from this eruption, it is said it was about 14.7 cubic kilometers, or about 15 cubic kilometers. And if we imagine 3 cities, Oslo, Helsinki, and Reykjavik, and let's imagine that we were about to pave the cities with some cement. That would mean that we would be able to pave Oslo with about 30 meters. We would be able to pave Helsinki with about 65, 70 meters. And Reykjavik with about 50 meters of cement, the whole city. You can imagine that's a lot of material. And the lava field, Skaftárelda, named by the Skafta fires, it covers about 600 square kilometers, about 580 or so. And if we imagine these cities and how much volume, square kilometers, then we could say that we have about 1.5 Oslo, 3 Helsinkis, or 2.5 Reykjaviks. That is the size of the lava. So as you can see, the impact from this volcanic eruption is quite big, not only for Iceland, but also on a global scale. And Jóhannes, he has also taken a little bit of points together to tell you a little bit more about the climate impact it had, and brought along some of threads called Nornahaur, which you can sometimes find after eruptions. And the descriptions from Jón say that these threads had fallen from the clouds and were seen on the ground. These are from
the lava show here in Iceland, so
Yeah.
they're man-made.
They're man-made, but
and
they're
called-
similar in the look. So
Exactly, and called pellets here in English.
Hellis here, yeah, exactly.
But which is here in Iceland.
Which
But
is
they also played a large role during the eruption of spreading the fluoride around, and it will settle on the ground, dissolve, and then grazing animals will eat it with the grass, along with the ash. So that's the main source of the fluoride poisoning that killed a lot of the livestock here. But you already mentioned the sulfur and sulfur dioxide that came up with the eruption, and I'll show you guys the witches here a little bit later. And that's the largest climatic impact it had during that eruption, and is the largest climate impactor from volcanic eruption. But also another one is ash. And in short, what volcanic eruptions have, the effect on the climate they have is cooling of the lower atmosphere and warming of the upper atmosphere. So, for example, if we see the clouds here, the gas thrust from the eruption will lift the eruption column, and the eruption column will contain a lot of ash, but also a lot of gas. And the gas is, of course, much lighter than the ash itself. So the gas is able to stay aloft in the atmosphere for a much longer time than the ash. So the ash has effect on the region around the volcano much more, but can also block out the sunlight. And that's the main factor that these gases and ash have on the climate, is blocking out the sunlight. So it creates cooling. And the higher it goes into the atmosphere, especially the gas, the longer the cooling will be. And I'll mention the climate change for about a year, up to 4 years or so in cooling. Larger eruptions that are explosive eruption lift the column much higher into the atmosphere, about 20 to 40 kilometers. They can cool the Earth, or at least one of the hemispheres, for up to 3 to 4 years or so. So these are not long-lasting climate effects from eruptions, but they can have a large impact for a few years. But as I mentioned, the ash usually only cools much of the area around the volcano itself, because the ash is heavier and will settle much quicker. But a fine ash can reach fairly high into the atmosphere and can take a round trip around the planet and cause cooling like that. But the most important thing is the sulfur, or sulfur dioxide, because they are gaseous, but they become particled in the atmosphere through oxidation. They pick up basically LAKI, moisture and humidity, in the atmosphere, and so they produce larger amount of hydrochloric acid, so it expands basically. Now what happened in LAKI, you get the ground haze, which destroyed everything here in Iceland basically, or you also get the haze up in the air. And it hit the jet stream here in Iceland, which is about 10 kilometer height during the summertime. So a lot of the haze was brought over Europe. But unluckily for the Europeans at the time, there was a high pressure system over Europe that pulled down the air to ground level. So Europe also got this haze. But normally this does not happen because the sulfur is much higher into the atmosphere. So high pressure systems are unable to pull down the air mass, and therefore we don't get the haze spread normally. And the reason for that is the difference of the eruption types. So you can see the crater roof here, and this is effusive eruption. So we're fairly well known here in Iceland to effusive eruptions. Effusive eruptions are basically when lava just pours out of the ground. It can form fountains of lava up to 1.5 kilometers in height in this case, but are normally around 500-600 meters or so. And there's very little explosive activity. Here in Iceland though, because we have a lot of groundwater, we can get explosions in the first couple of days usually in these eruptions, and they create the highest columns. So most of the sulfur that went into the upper atmosphere during this eruption came through during the first couple of days of each new fissures being open. But of course we know explosive eruptions very well as well. Tambora, for example, is very well known. And we've probably all seen pictures from Stromboli, for example, in Italy, the decent sized eruption the other day. And so these are, they will fracture the lava much more, so create a lot of ash, but you can also get a lot of gases coming from them as well. But the eruption column then in them is much higher, so you get higher elevation of the ash cloud and the gas cloud up. But this gas cloud will circumnavigate the planet and cause the cooling because of the refraction of the light. But there are other factors that cause climate change through eruptions. There's a lot of hydrochloric acid that goes into the atmosphere as well, and a lot of water vapor, and it destroys the ozone layer. So when Tambora exploded, for example, it depleted a lot of the ozone layer in the southern hemisphere. But luckily, eruptions like these, it depends on the location on the planet where they are, what effect they will have. So LAKI, for example, in the northern hemisphere will only affect the northern hemisphere. And if there's an eruption on the southern hemisphere, it will only affect the southern hemisphere. If it's near the equator, it can go global, basically. And this is due to the wind patterns of the planet. Most of the energy from the sun is hitting around the equator, and the weather system is basically distributing that energy throughout the globe. So it's very hard for any gas that's released into the atmosphere to cross the hemispheres. So this is both a good and a bad thing. But most of the debate about volcanoes is usually carbon dioxide, though, and people are probably most familiar with that. And there is a lot of carbon dioxide released by volcanoes from eruptions, but the average is, I think, 110,000 megatons per year on average. But that sounds like a lot, but it's still 10,000 times less than human released carbon dioxide into the atmosphere. So before we started to pollute our own atmosphere, back in the day, massive eruption could have affected the climate much more than now, because now it's basically just a drop in the ocean. So in short, the biggest climate effect is cooling for a few years, but after that, everything recovers, so that it's not a long-lasting climate change. If you have time, we can go a little bit deeper into one event. It's called the Deccan Traps. It's a type of eruption called flood basaltic eruptions. Anybody heard about them? So these are similar to LAKI eruptions, effusive eruptions, but these are multiple eruptions that happen over the course of maybe 75 to 100,000 years, and there's a massive amount of lava that comes up, and this is a global climate changer. And they have been linked to the extinction of the dinosaurs. It's a little bit varied, but they release so much carbon dioxide that they will cause climate change or climate effect change. So, but LAKI in itself, and most large eruptions, they happen maybe once a century or so. They will change the climate for a few years.
Yeah. All right.
Thank you.
Thank you.
And now we have some pictures from the students, and start with, let's see. Anita is first.
I chose this picture because I thought it was so beautiful and I don't know. I used my sight to sense it, and
Why did you choose this?
I chose this because I thought it was so beautiful and it's so big.
And what influence did it have on you?
Not that many, I think.
Okay, thank you. On the picture.
Huh.
Tell us what is on the picture.
This is Julius and Anita, and the beautiful landscape. Shown.
Sight.
Yeah, sights.
See.
Yeah, seen.
And what influence did it have on you?
This was just so beautiful landscape.
Okay.
So yeah.
Tell us what is on the picture.
It's grass, and I choose this grass because it reminds me of myself. It's small and cold, and I used my eyes to see this, and when I saw this I got the feeling of freezing. I choose to take this picture because I took this picture of the road because it is giving us the chance to go up here like deeper in Iceland and see the nature. I chose this picture because I thought it was...
What is on it?
Oh, it's the mountains or LAKI, I don't know. I chose it because it's beautiful and I used my sight as a sensing and it made me mesmerized. Yes.
Here you can see the lava covered with snow. It's from the Skattar fire and I think it's beautiful. That's why I took it.
Did you use any senses other than sight, or did you hear, or smell, or feel
Yeah,
anything?
I heard the wind and felt the snow.
And how did it influence you?
Um,
What feelings did you got when you...
Cold. Yeah. Okay, thank you.
Tack.
It's a photo of water. Took it because I thought it was the most beautiful one out of the environment. I used my sight. It had I just got the feeling of winter when I looked at it.
Okay, thank you.
This is a photo of the landscape and the snow. I took this photo because I thought it was beautiful and it looks like Oreo. I used my sight and I chose this because I thought it was very beautiful. Yeah.
Thank you.
I took this photo of a mountain with the snow and the sun and the sky. I took it because it was beautiful and I used my sight to take it.
Okay, thank you.
I took this photo of the water with the mountains because I thought it was amazing how it can be just a still pond in the middle of nowhere of the mountains. And yeah, I used my sight to understand this. And yeah.
Yeah, how did it make you feel?
It made me feel very relaxed. Also with no wind or anything, it's very relaxing and yeah.
Thank you. So we're quite finished now here at LAKI, but we'll see you at Geoheritage after a couple of hours.